Unit 5B, Lesson 2, Transformations of Graphs. We talked about transformations earlier in the year, but all we really did was given an equation, compared it to the parent function, the original function, and described the transformations. Vertical translation up 2 units, horizontal translation to the right 1 unit, a reflection across the x-axis. You just had to write out those different transformations. Now we're going to revisit that and look at notation we can use to describe transformations, as well as how it affects the graphs. Here's a review of the ones we talked about earlier. We had vertical translations up or down. We had horizontal translations left or right. We talked about reflections across the x-axis. And then we also talked about vertical stretches or vertical compressions. Compressions we can also think of shrinks. A stretch if the absolute value of a is greater than, and a correction we need to make here is that this should be a 1. It's absolute value of a greater than 1, that's a vertical stretch. If that absolute value of a is between 0 and 1, then it's a vertical compression. So make sure you make that change in your notes. So now we're going to talk about the notation we can use to represent some of these transformations. Rotations, we didn't deal with those. Earlier in the year we talked about reflection, translation, dilation is changing the size. So we're just going to look at some of the notation. The subscripts on the letters are used to indicate specifics about the transformation. So whether we're going left or right, whether we're reflecting it across the x-axis or the y-axis, those things. Okay, so the first example, this is lowercase r, which indicates a reflection, and we see the subscript is the y-axis, so this tells us we're taking our original shape or graph and reflecting it across the y-axis. Now we look at the next one. We have a capital T, which stands for a translation, and if we look down below the subscript, the first value tells us the x, and the second value tells us the y. So this tells me we're going to move 2 units to the right. We have a horizontal translation 2 units to the right, and then a vertical translation 1 unit down. First number tells me my x value left or right. The second number tells me my y value up or down. So it's a horizontal translation 2 units to the right, and a vertical translation 1 unit down. Now to the next example, which transformation of the graph of y equals x squared would result in the graph of y equals x squared plus 2? So we're adding a value of 2 at the end of our function. If we look at our notation from before, if we have the original function, we're just adding some value at the end. That represents a vertical translation. So looking at our options, we have a dilation, a translation, a reflection, and a rotation. So we know this is just a translation, so it must be option B. So this tells us we're moving 0 units in the horizontal direction, the x direction, and up 2 units, a vertical translation, up 2 units in the y direction. So the correct choice would have to be B. In this example, the parabola shown in the graph undergoes a reflection in the y-axis. What will be the coordinates of the turning point after the reflection? So we're looking at the y-axis, we're reflecting it. That essentially creates a mirrored image. So we're taking this image and reflecting it across this axis. The turning point is going to refer to the x, or the vertex of this graph. That's where it changes from, this case, decreasing to increasing. The vertex represents the turning point. So after this reflection across the y-axis, we want to determine what is the new coordinates for that turning point, that vertex. A reflection across the y-axis, that's not one we've worked with previously, so we're going to introduce it now. What's going to change in the coordinate points is from x to y. If this is our original ordered pair, the only thing that's going to change is the x value, and we're going to negate it, make it the opposite. So if the original x value was 3, now it would become -3. If the original x value was -2, now it would become a +2. So the x value is going to change to the opposite. the y value is going to stay the same. That's what occurs when we have a reflection across the y-axis. So the first thing we can do is look at some of the points of the original graph. We had our vertex at 3, -1. We had some points at 5, 3, and 1, 3. We know from our notation that after this reflection across the y-axis, the only value that's going to change is the x value, and it's going to become the opposite. So the new image, the new point after the reflection for 1, 3 is going to be -1, 3. The new point for 5, 3 is -5, 3. And then the new point for 3, -1 would be -3, -1. So we have these 3 points that we can plot, and now we can see the graph of the parabola after the reflection across the y-axis. You can see it's a mirrored image across the y-axis. Now to answer the question, what will be the coordinates of the turning point after the reflection? So we said the turning point in the original was 3, -1. So now the turning point after the reflection is going to be the ordered pair -3, -1. So to answer this question, we actually didn't even have to look at this graph or create this new graph after the reflection. We can just look at the original turning point, know that the x value is going to change if it's a reflection across the y-axis. So we make -3, -1. Plotting these other points just gives you a visual of what's happening with this reflection. Now to the last example, the graph of y equals f of x is shown. What is the graph of y equals f of x plus 1 minus 2? So this notation, if we have plus 1 within the function, looking back at our notation, we have plus a value within our function that is a horizontal translation to the left. So we're going to move each point 1 unit to the left and then 2 units down. So we're just taking each of these ordered pairs. This first one is -2, or +1, -2, 1. So we want to move that to the left 1 and then down 2. So if I move that to the left 1, I'm at -2, -3, and then down 2 units would get me to -3, -1. Now I go to the next point, which is -1, +2. If I move that to the left 2 units, or 1 unit, excuse me, we'd be at -2. And then if we moved it down 2 units, that would put us right on the x-axis. The next point is at 2, 3. So if I move it left 1 and down 2, I would be at the ordered pair 1, 1. Then the last point is at 1, 2, 3, 4, 5, 6, 7, and a +4. So if we move that left 1 and down 2, that's going to put us at the ordered pair 6, 2. So 1, 2, 3, 4, 5, 6, up 2. Now I have all these new points, and I can construct a graph going through all those points, continuing to the left and to the right. So just understanding the notation, this represents a horizontal translation 1 unit to the left, and this represents a vertical translation 2 units down. We can use that idea to now graph the new image after that transformation.